So hello everyone, welcome to this first Horizon IQ activity using Zoom. So we will be using breakout rooms today for a portion of the activity. It is the first time we do this, so we hope everything will go well, and we appreciate any feedback that you have regarding the use of this feature. It's not in Teams, so that's why we are using Zoom today. And lastly, I want to thank Camille, Eli, and Augustin, who helped organize this awesome activity. And they will now introduce our invited speaker for this workshop. So thank you, everyone.
Yes, so hello, everyone. So today we're pleased to host Catherine Klauss for this Horizon IQ workshop on science writing. So to introduce Catherine, she's a physicist, but also a science editor based in Boulder, Colorado. And she has been working over 10 years on atoms interactions at ultra cold and also room temperatures. And more recently, she has been working as a science writer, editor, and also as a teacher working to help scientists become better communicators. And so she has taught and implemented science communication strategies at JILA, at IBM Quantum, and at NPR. So you will probably learn more about her at the end of the event because there's going to be an open discussion. So basically the event will be divided into two parts. The first part being an interactive workshop of around 1.5 hours, where you will be separated in groups of 2, but Catherine is going to give more details about that after. And the second part will be an open discussion about talking with Catherine about her experience as a woman in science maybe, but also as her experience going from research to writing about research. Well, I'll let Catherine take over now and explain the structure of the workshop, and I hope you enjoy your time.
Thank you, Camille, for that introduction. Hello, I'm Catherine. Although Camille, you say my name much more beautifully than I do. I wish I could pronounce it with that French accent. Yeah, thank you all for coming today. I just wanted to get a quick poll. How many people were able to bring a draft of writing with them? Was anyone unable? Is anyone here without anything to edit? Okay, all right. So we have a few. Carl, you're the one in charge of the breakout rooms, correct? We maybe want to make sure that anyone who's, maybe we could like duplicate so that the people who haven't brought anything to write, they can maybe be given a second, like, so someone's piece can be given twice to 2 different people so that everyone has something to edit with. Okay, great.
Yeah, so if you don't have anything prepared, just send me a quick message private in the chat of Zoom, and I will try to, mix the breakout rooms accordingly.
Okay, great. Yeah, because the goal here is that I want everyone to have a piece of writing that's not their own to be able to edit. So when we start going through different tricks of quick ways that you can improve the readability of your writing, I want everyone to have a piece of writing that they have not written themselves to be able to look at it critically and say, okay, we would change this, change that. Okay, great. With that, I'm going to get started. So I'm just going to go ahead and share my screen. We'll go to PowerPoint. I'm going to share. Okay, can everyone see my screen? All right, yes. Great. Okay, so I've already been introduced, but I'm Catherine Klauss. I'm going to talk to you guys about science writing today and how to improve your science writing. So why do we want to write? Hopefully I don't need to push this motivation on you guys too hard because everyone decided to come to a seminar in science writing. But science writing is really like the last step of science. There's that phrase, publish or perish. If you don't publish your work, did you really even do science? The last step of writing, the writing is necessary to get credit for your work, to let people know this is what you've discovered and to share that knowledge with other people. And it's also a big part of finding collaborators, whether in your field or even outside of your field. And it's the step that we need to do to secure funding. So you can't convince people to give you money to keep doing the research that you're doing unless you can write about why what you're doing is important. And why would we want to write well? So writing well, there's from Francis Crick was once quoted saying that there's no form of prose more difficult to understand and more tedious to read than the average scientific paper. So I don't know who else might share this feeling, but I mean, who here has ever like who here has ever read a scientific paper and kind of like had to do a second or maybe third read over to understand what's going on? Because I know I definitely, whenever I'm reading a scientific paper, have to read it multiple times to figure out what was the point here. And ideally, when we're writing well, we should be able to write in a way that people can understand on the first go the main point and what are the purposes that we're trying to convey. So, and why would we want to write stories then? So why would storytelling be an important part of science writing? Well, the best scientists are storytellers. So we've got Einstein, Feynman, Carl Sagan. These were all scientists that they were able to engage the public because they were able to take science and turn it into a story that many, many people could understand. And engaging stories are what encourage readers to want to learn more about your research. So stories serve a purpose, and that other people outside your field who would normally have an interest can suddenly get hooked and they can be interested in what you're saying. And when people learn about your research, this is how your ideas travel. This is how you're going to find collaborators in other fields, and this is how you're going to get more funding. And unfortunately, bad writing can also stall science. So Gregor Mendel, known for his research on peas and basically the founding of genetics, he's an example of when like bad science writing actually harmed science. So Gregor Mendel, he published a couple of papers and he presented his work at various conferences, but many scientists didn't understand what he was trying to say. And so his work didn't pick up. It kind of got lost. And he was just like, he didn't do much about it. He didn't try and like go and make sure that people really understood what he was trying to say. And his work on peas and genetics, it was actually forgotten until it was duplicated after his death. It was actually like 16 years after he died. Two other scientists went and they repeated that experiment unknowingly. They thought they were doing original work. And when they went to go publish it, they found his lost papers and they were like, oh, we were not the first people to do that. And this is unfortunate for science. So when science gets lost because it's not communicated well, science gets stalled. We could have had another 40 years working on genetics and we could have gotten much farther than we were today. So that's the whole background of why science writing is important, why science communication is important, and it can help you whether you want to become a science writer or you just want to be a scientist that knows how to write very well. And today we're going to cover two things. We're going to cover the basics of storytelling, and we're also going to cover some quick tricks to improve readability. And we're going to have some peer editing practice. The peer editing practice we're going to include with the 5 quick tricks. And the basics of storytelling, I'm just going to go through that very quickly because storytelling is a very important integral part of writing and science communication. We're not going to be able to fit the peer editing portion into the storytelling bit because honestly, we could do like a whole 4-hour seminar on how to build up a story because you need to bring in storyboarding. And I didn't think that we'd be able to, within an 1.5-hour seminar, be able to edit each other's work to like figure out where the story is. But I did want to cover it today because it's just a very fundamental part of what science writing is. So getting into storytelling, the first thing that's very important is knowing that what your job is as a storyteller is to make the reader's job easy. That's what you're trying to do as a writer. What does that mean? It means in storytelling, like the audience is king. They're going to determine your tone, your word choice, your length, even your content. What you put in or what you don't put into your paper should be determined by who is your audience. And if there's only one thing that you remember from today's seminar, it's that the audience is king. Just remember that whenever you're trying to decide, oh, should I write this or should I write that? You need to ask yourself, what does my audience want? And depending on the publication that you're writing for, the audience is going to determine like what's the content, what's the tone, how are you going to write this? So for example, these are 2 sentences that I pulled from 2 different magazines on relatively the same topic. So in the Atlantic, which is, I mean, they cover a wide range of stuff. They cover politics, they also have science writing. When they were writing about microbes, the author Ed Young was writing, you know, it wasn't always like this. Antoine van Leeuwenhoek, the Dutchman who first discovered the microbial world in the late 17th century, was delighted to learn that multitudes of living things existed below the threshold of our perception. Even when he saw microbes in the plaque between his own teeth, he was more amazed than repulsed. So that's written for a very broad audience, for someone who's not necessarily a scientist, someone who's just curious about the world and wants to learn more. Versus if you see a similar story published in Nature, which is a publication mostly for scientists, but not for a specific field, you're going to see a sentence like this one that I pulled out. Antoine van Leeuwenhoek, the first observer of bacteria, would be surprised that over 99% of microbes in the sea remain unseen until after Viking landers set out to seek microbial life on Mars. So it's much more to the point. We kind of skip over the metaphors, like the broad visuals, but it's still introducing specifics. It's still giving us some broad context of what's going on. So that's an example of how writing for the general public, writing for a science public, we're taking the audience in mind. And it gets even more specific than that, because if you go not into Nature, but into the equivalent of what would be physical review letters, this sentence is not taken from PRL, but it's the equivalent for physicists of what that journal would be. You're going to see something like epifluorescence microscopy and direct viable counting methods have shown that only 0.01 to 0.1% of microbial cells from marine environments form colonies in standard agar plates. So they just skip right to the details in that point, because this is written for a very specialized audience. All right, so when you're writing and you need to keep your audience in mind, these are the questions that you should ask yourself about your audience, and you need to be able to answer these before you can start writing. So the questions are like, what do they know? What do they care about? Do they know this specific word? Do they know what this concept means? And more importantly, you want to know what your audience wants to know from you. So when someone's reading your paper, they're going to want to know, like, what did you do here? How did you do it? Why did you decide to do it that way? And what does this mean? What caused this to happen? And can you give me an example of this? And what you never, ever, ever want your audience to wonder from you is this important? Because once your audiences start to wonder, is this important? Do I need to know this? They're no longer paying attention to what you're trying to say to them. They're in their own head at that point, trying to figure out, they're being skeptical of you, and they're trying to figure out, are you actually, faithfully leading me through the story? And like what I need to know to get through here. They're going to start wondering, like, okay, do I need to find someone else to convey this information to me? So going back to like you're at your job, it's to make the reader's job easy. You can use a story to make the reader's job easy, because in science we have a lot of complicated things. We have how the experiment was set up. We have how can you guys see my mouse as I move it over the screen? Yes. Okay. It's been hard to not point at things. This isn't in person. We have the experimental setup. We have the basis of like what we're trying to test, like what our hypothesis is of how things are going to interact. We have the mathematical model of like what should happen when we do this, and we have the data that we found. And these are all like a lot of very complicated things that, I mean, we will spend years studying this ourselves, and then it's our job to convey it to somebody in just a short amount of time they have like 10 minutes to read our paper, and we're trying to convey stuff that we spent 3 or 4 years studying. So in that situation, you want to then use a story to make this information more relatable to someone else. So when you fit it into a story structure, which humans are, we're primed for stories. Like, that's how we get all of our information. Once you fit it into, like, okay, the experimental setup is what we began with. The rising action in the story is the model of what's going to happen. The climax is the data that we found when we ran this experiment, and the resolution is what this tells us about the world. Suddenly, for your reader, they are able to put in context all these complicated parts. And so that's the power of using a story in science writing. And whether this is writing a science paper for a science audience or for a general audience, the story ends up being an important part of that. So I wanted to go through very quickly what actually fits into the 4 parts of a story. But first I'll go through what there is like a little bit of backlash sometimes. Like, some scientists, they worry that a story is actually, there's gonna be like fiction, or if I turn my data into a story, it means I'm manipulating it, or I'm spinning my data in order to try and sell it. And that's not what I'm trying to say, like, a story needs to be. A story is just an effective way to communicate your data to the public. And you're not only communicating the data, but you're communicating the nuances and importance of the research that you've done. Because you wouldn't just publish your data. You wouldn't just say, like, okay, here's the data, let's just publish that chart in the journal, that's all we need. And you wouldn't just take your lab notebook and publish that either, because you wouldn't be like, okay, we just set, the parameters to this, and then this is what we saw. What you actually publish when you publish a science paper is you publish a question, and then you publish the method that you took, and then there's the results, and then there's the interpretation of these results that you got. And the middle 2, the method and the results, that's really just your science. That's saying, like, I did this and I saw that. That's science right there. And it's including the question and the interpretation around that is what's making it into a story. Because now you're saying, like, I thought this about the world. The rising action was, I decided to then do this, and then I saw that, and then the interpretation is, and now the world looks different in this way. So in that way, this question, method, results, interpretation, that's the normal way that we fit a science paper. This then fits into this plot structure of, like, the question is the beginning of your plot. The method is the way that we start building up, okay, we're gonna go and test the world. The results is that climax, and the interpretation is, like, the world looks a little bit different now because of what I did. And this is how you developed a story out of your science paper. I'm going to explore just a little bit more into what actually goes into this story. So I'm going to call them not now by, like, the science terms, but by the story terms, which is like opening, challenge, action, resolution. Those are the 4 parts of any good story. And I want to cover what fits in to each of these 4 sections when you're building a story. And I want to compare this to a normal story. And so the most well-known story of our generation right now is Harry Potter. So I've decided to take the 4 elements of a story, and we're going to go through how these fit into Harry Potter and the Sorcerer's Stone. So first off, we have the opening. So there's 3 different things that need to be addressed in any good introduction or opening. And the first one is, what is the story about? So for Harry Potter, for example, we know that Harry Potter is about an orphan who finds out that he's a wizard, and he meets 3 friends. And we also need to know in any good opening, like, what needs to be understood to follow the rest of the story? Like, what do I, as the reader, need to know about this character in order to follow along? And in Harry Potter, it's that, Harry is very good at flying on a broom. His friend Ron is really good at chess, and we know that Hermione is she's book smart. And then finally, you always need to have a larger problem that you're addressing. So in Harry Potter, there's a lot of small problems that come along, but we know the entire time that the most important thing is that he's fighting off Voldemort. And it's really, really important that you always need to have one main challenge. And your audience needs to know what's that one main challenge, because it keeps your audience, it helps them focus, and it helps them know what's important. So they'll never have to wonder, is this important? They know what's important and what's not important as long as they know what your main challenge is. So once we get on to the challenge section of the plot, there's two different things that we need to know. And the first one is to solve the larger problem, what needs to be accomplished. So in the Harry Potter first book, it's that Harry Potter needs to get the Sorcerer's Stone before Voldemort does. And then we already know early on what makes this difficult. Well, it's guarded. It's guarded by this three-headed dog, and there's going to be other challenges that come along the way too. Once we know this challenge, we can then set forth into action, or the ways known as the climax of the story. So what's going to happen while he addresses this challenge? Well, this is when you get to the point in the book or the movie, if you never read the book, this is about 3/4 of the way through. So the opening and the challenge are honestly the first 3/4 of any good story, and the action happens close to the end. You see that Harry Potter is like, all right, I'm gonna go and take on these 3 dogs. And then we see more challenges occur. So we see one challenge, we see that Hermione had to use her book smarts to get something done. We see another challenge where Harry had to use his broom flying skills to finish another challenge. And then we even saw a challenge where Ron had to use his chess skills. So what's important here is that all of the challenges, all the action that happened, they were overcome using information that we gave, that the audience got in the introduction. So this is what makes Harry Potter a very good story, is all the information was given to the audience in the introduction, and then they see how it unfolds during the action time. And then finally, any good story, you need to finish with the resolution. And in your resolution, you need to know what did you learn from what happened? What did the character learn from what happened? In Harry Potter, it was that he learned that he can actually handle the Sorcerer's Stone because he has his parents' love. But we need to know not only just how the main character was affected, but how the world changed as a result. So in Harry Potter, it's that because of his actions, Gryffindor won the House Cup. So we get to see how a smaller action affected the whole world. So in like your science paper, this might be, we saw this result, it made us think this, and then you kind of go into, this is how it's gonna have implications, like larger implications. It could mean this and it could mean that. It could affect this field in that way as well. And then finally, you're gonna have, what are the next steps? So at the end of Harry Potter, they get on a train, but you know that they're coming back next year because this is a school where they come back. And in a good science paper, a good science story, you always want to cover like, what are the next steps? Like how could you take this science to the next level? So those are all the elements of a good story. And I wanted to cover that real quick to just so that you have them. Unfortunately, we won't be able to peer edit them, but I do have an example of a abstract. It's a real abstract published in Science. And this here is an abstract where it uses story very clearly. And you can see how it makes it easier to understand, because as a human, this is how we would expect to get it. So in this abstract, they say that laser-cooled and quantum-degenerate atoms are being pursued as quantum simulators and form the basis of today's most precise sensors. So that there is their opening. We know what it is that they want to talk about, how this is going to be related to like in the larger frame of things, and we kind of begin to get a bit of their question of like what is like more information that we're going to know and like where we headed from this. And then they get into the second sentence is, a key challenge toward these goals is to understand and control coherent interactions between atoms. So here they've stated their challenge very succinctly. In fact, they even just use the word challenge, which as the reader, it makes it very easy for us to understand this is what they're trying to do. There's no reason to like beat around the bush about it. You want to make it as clear as possible. This is a challenge that we're trying to deal with here. Then they get into the action. This is what they actually did in the paper. So in their abstract, they say they observed long-range interactions mediated by an optical cavity, which manifests as tunable spin-spin interactions on the spin 1/2 system, composed of the millihertz line width, clock transition, and strontium. This leads to one-axis twisting dynamics, the emergence of a many-body energy gap, and the gap protection of the optical coherence against certain sources of decoherence. So they just real quick went through, this is what we actually did. This is what we saw. Then they get into the resolution at the end. Our observations will aid in the future design of versatile quantum simulators. In the next generation of atomic clocks, they use quantum correlations for enhanced metrology. So they end it with saying, this is how it's going to affect the larger world. This is how it's going to like change the world. This is where we expect to see the next steps, where we expect to see this stuff be implemented. And so this is a fantastic abstract because it follows that story structure. They certainly could have taken this information and put it in a different order. They could have started with the action of like, we observed this. And then at the end said like, it's been challenging to do this. They could have done that, but as a reader, you would be reading this, you wouldn't understand, why do I care about what they've done here yet? You want to get that challenge first. So that was a real quick run through on the basics of storytelling. And like I said, I wish that we could spend some time practicing and workshopping storytelling, but I think that it would be hard to come into a group and start storyboarding each other's work early on. I just didn't think it would be possible to fit into a 90-minute seminar, but I want you guys to have that, because the next time that you go out writing an outline or an abstract, it's very helpful to take that storytelling element and use it in your writing. But for now, I want to go on to like the 5 quick tricks that can improve readability in any writing. So this could be applicable for writing a science paper, writing an abstract, or writing an article for the general public. And I'm going to incorporate peer editing practice with this. So I'd like to go into the peer editing section, and this is what's going to happen. We have a few rules about how peer editing is going to work here. And the first rule is, do not take the feedback personally. So if someone says that, hey, I don't think that this sentence was clear, I don't like how it was written, that doesn't mean that, you know, they think everything that you've written is terrible, or that they don't like you as a person. The feedback is, don't take it personally. It's just going to be given in terms of like what you've written today. And also don't worry about being judged by someone's writing. I know like sometimes I can feel like a little bit hesitant to hand what I've written off to somebody else to be edited. But we're just going to assume that all writing that was brought here today was rushed and unedited, and that everyone finished it about an hour before this class and didn't even have time to review it, because that's the best way to go into this. Also know that you know your science better than anybody else. So someone might suggest like, oh, maybe you should rewrite the sentence like this. Those suggestions, they may not work all the time. You might be like, well, that's not factually correct anymore. And so you have the right, so you don't have to incorporate any suggestions that you get. But do recognize that if someone is saying like, oh, like maybe you should rewrite this sentence like this, they might be saying this sentence wasn't clear to me. Like I didn't understand exactly what you were trying to say. So even if you don't want to take the suggestion as they did, do take a second look at that sentence, because it does indicate that maybe it wasn't as clear as you first thought it was. And third, you want to respect your editor. So while your editor may not know how to best fix the sentence, or they may not, you know, fully understand everything that you've done in your science, your editor does have a better sense than you for what sounds clear, because they're not in it. They're not in their head, and they don't have the curse of knowledge, in that they know exactly how everything fits together. So they have a better idea of, does it work when it's written on paper in this way? So that said, we're now going to break off into pairs with the help of Carl. You're going to be broken off into pairs, or perhaps even multiple if there's some people who haven't written a piece here. And I want you guys to share your draft with your partner. So either if it's on Google Doc, you can just send them a link. If not, you can do a file upload and do a quick introduction of your draft with your partner. Let them know who is your audience, what was the intended publication. You know, we're trying to put this in Science, you're trying to put this in at NPR, and then discuss like what's the purpose and what is the main point that you're trying to get across. And then I want you guys to take the remaining 4 minutes and try to read through your partner's draft. You don't want to edit it here. I just want you to get familiar. Like, okay, first they talk about this, then they talk about that. We're going to be editing in small chunks as we go, but you do probably want to get prepared to edit. So put yourself in review mode or editing mode, depending on your whatever software you're using, or just change the color of your font so whatever you type, when you hand it back to the writer, they'll be able to tell their writing from your writing. Do we have any questions before we go off into pairs here? Okay, no. All right. Well,
okay.
We're gonna try like just going off into the breakout rooms and then coming back in 10 minutes. All right, is this everybody?
No, I think there's still 3 people missing. Shouldn't be long. I thought that when I clicked close, it would close, but there was a 60-second timer.
Okay.
So
Just an extra minute. Okay. Did
my
everyone who's here have a chance to read through their partner's or at least somebody else's piece? Kind of get like a quick idea of what's in it. So when we're going through and editing it, we don't have it with fresh eyes. Let me just say right now, like if your partner has given you a very long piece to edit, feel free to just pick an excerpt for this editing session. So we're going to go through like 5 different ways that we can edit. But because we're going to go through like 5 different ways, we're only going to have about 3 or 4 minutes for each different section. So if you have like 5 pages to edit, you're not going to be able to edit through all of it. So feel free to be like, I'm just going to focus on this one page if you got a very long piece to edit. And then, you know, your partner only gets 1 page edited, but that works out. So if it's too long, just pick an excerpt to write. Okay, so I think everyone is back now. Yes? Yep. Okay, all right. Welcome back, everybody. I hope that your breakout room worked, and I hope that you were able to trade your paper and that everyone has in front of them another person's writing that they can edit. If you do not, please speak up right now so we can get things fixed. And no? Okay, it sounds good. We're gonna move on to 5 different tricks on how to become a better writer. And so we're all going to be implementing this on someone else's writing because it's easier to look critically at someone else's writing. We always have kind of trouble editing our own writing. But when someone else is looking at our writing, you know, they can point out, oh, here's where you did this, here where you did that. Everyone else has like a much better eye than we do on our own writing. So we all have someone else's writing where we're gonna move forward with. So as I talk through this, we're gonna like go through some examples and then we're gonna pause for about 3 or 4 minutes each time for you guys to search the writing that you have in front of you to see if that example or trick will apply to this writing. So the first trick that we have is that you want to be intentional about active or passive voice in your writing. So I don't know about you guys, but when I was like working as a scientist, I knew, like I always heard all the time, like, oh, scientists always write in passive voice. And I was like, yeah. And I didn't really truly know what that meant. And nor did I understand that passive voice is not always bad. It has a purpose. So the difference between active and passive voice, we have a very simple sentence to go over it. An active voice would be John threw the rock. And in this sentence, we have John is the noun and he is doing an action. John's throwing a rock. Passive voice is when you say like the rock was thrown by John, and it's by John is an indication that this is a passive voice because it's done something. The object is the one doing the thing. You can also take out the by John with passive voice. You could say the rock was thrown. This is also passive voice, and we've just removed information of like who did it. So in passive voice, the noun is actually the acted upon. So the rock wasn't throwing anything. The rock was getting thrown. The verb is acting on the noun in our sentence, and that means that we're in passive voice. So that's the difference between active voice and passive voice. Now, when would you want to use active voice or passive voice? You want to use active voice for better story structure and less words. Active voice is going to make things a little bit more clear for your reader to understand how the story works because they're looking for who did what. So for example, here's a passive sentence. This hypothesis is supported by the observation that the timing of spring runoff is significantly different between natural and modified basins, more et al. So this is passive because the hypothesis isn't doing any supporting, it's getting supported by something. And then by the reader, we have to understand what's being supported. It's being supported by the observation, and this observation was in more et al. So if we wanted to rewrite this in active voice, we'd have to figure out what's truly doing the action here, what's supporting this. And one way to rewrite this would be then to take the more et al. And then put it up in the front. So more et al. Support this hypothesis, observing that the timing of the spring runoff is significantly different between natural and modified basins. When an audience reads this second, the active sentence, it's a little bit clearer for them because they don't have to wonder this hypothesis supported by this and then try and figure out, okay, that they're therefore saying that more et al. At the end of the sentence is the one doing the supporting. It's just the who did what is in the top of the sentence. And they can figure out, okay, this is the important stuff here in the beginning. When would you want to use passive voice instead? Passive voice is really good for hiding the actor, so hiding what's doing something. So for example, this is an active sentence. Undergraduate research assistants cooled the samples on ice, returned them to the university, and froze them until I used them. So that's an example of something you might see in a methods section of a paper. But it comes off really informal because as me, the reader, I'm like, I don't care who cooled the samples. I just care that they were cooled. So in this is the case where you might want to use passive voice to hide the actors and what was done. You would say instead, samples were cooled on ice, returned to the university, and frozen until later used. In this case, we've removed the actors, the person doing the verb, because they're not important. And again, we never want our audience to wonder, is this important? We only want to tell them the important things. There is a time when information can be hidden in passive voice and we'll realize that we are including the actor without meaning to. So for example, this is a passive sentence. Potassium was found to not react. What we're hiding here is the by us. It's like when we said the rock was thrown by John. We don't say by us, but we're saying it was found by us to not react, but we've removed that. So we're great, we've removed the actor. If you put this now in active voice, you'll see that we found the potassium did not react. And we realize, okay, like it's not important that we found this. But then you can understand that there's hidden information here. We see that we have this verb found. And is this actually important that we found it? Could we not rewrite this entire sentence to just say what's important here, which is that potassium did not react? So we can actually we can write this in an active voice, but then remove that extra information that wasn't important, which was the was found part. You could just say potassium did not react. And that is a much more concise, succinct sentence that like your reader, they're not going to trip over as much because there's not as many words that they don't have to wonder what's the important verb here. It wasn't found, it was that it did not react. So with that in mind, we're going to go on our first peer editing session. I'm going to give you guys 4 minutes and I want you guys to question, I can't read all these writings with everyone's bubbles everywhere. You're going to take a look at the writing that you have in front of you and you're going to ask yourself, like, is passive voice used anywhere? And if it is being used, is it to intentionally hide the actor or could it actually be rewritten with the actor in mind? And also check and see if active voice is used at any time when instead the actor should be hidden. All right, so hopefully everyone was able to kind of scan the writing that they had right now and search for passive or active voice. It's a little bit harder when we're all not in a room together to figure out, like, all right, does everyone have like a sizable amount of text? Were you guys able to find examples or not? Did you find that this was enough time? Yeah, okay, all right, I'm seeing a few nods here. Okay, great. Well, let's go on to the second step and we're just going to keep going through this writing through all the different steps. So hopefully you'll become more familiar with it and you'll be able to find things a little bit quicker. So step number 2 is you want to choose strong verbs. So the weak verbs that we end up using significantly is to be and to have. And to be, the conjugations are is, am, are, was, were. To have, we have has, had. We tend to use these significantly because we use them when we speak. And my theory is that we use them when we speak as a way to stall. So we use like, oh, I am trying to figure out how to do this, that, and want to do this. Using those weak verbs to be and to have, they fit into many different places, and we use them as a way to stall, to like making a commitment for like, this is the verb that I'm trying to do. Because really in our head, we're trying to figure out how do we want to make this? How do we want to say this? But when we write, there's no reason to stall. Like, you have all the time in the world to think about these thoughts in your head. You need to write them very succinctly out for your readers. So we want to look for times when we use those weak verbs to be and to have, and see if instead there are strong verbs that we've hidden in what are called abstract nouns. So for example, the sentence, understanding seasonal habitat ranges and distribution is critical for greater prairie chicken conservation and management. So in this sentence, we say that we have a weak verb. We have is, which is the conjugation of to be. And in this sentence, we can now look for, like, are there strong verbs that are hiding in this sentence? And there's actually 3 strong verbs hiding in the sentence. So we have the word understanding, which we're using as a noun, but it's from the verb to understand. Conservation is a verb, to conserve. In management, we're also using as an object here, and it's actually the verb to manage. So how could we rewrite this sentence in order to use strong verbs rather than the weak verb to be? We could say instead, before we can conserve and manage greater prairie chickens, we must understand their seasonal habitats. So as a reader, for me, reading this, when I see like a strong verb, it's easier for me to understand the who did what, or in this case, the what do we need to do. When we have those strong verbs, it's the did is very, very obvious, rather than in this case, I have to figure out, like, to be is not a strong verb. So what's actually being done? It's understanding, conservation, management. It just requires more mental hoops when you're using the weak verb as opposed to using the strong verb. So strong verbs hide in a lot of very common science words. So here's a list of a few common abstract nouns that I see in science writing. So movement, difference, suggestion, interaction. Analysis is a really large one. Development is one that I see very often. Investigation. And all of these are usually, they're verbs. And then there's also some abstract nouns, influence, approach, and yield, which their verbs are written the same. So what we're going to do now is we're going to go through the same piece that we have. And I want you guys to highlight any weak verbs that you find. So any is, am, are, was, were, have, has, or had that you see. And then ask yourself, are there any strong verbs in that same sentence? So obviously, if it's a very short sentence, like I am cold, you're not going to find a strong verb. But if it's a complex sentence that's using one of those weak verbs, check and see if there's a strong verb hiding in that sentence as an abstract noun and circle that. And then once you've found a weak verb with a hidden strong verb in that sentence, then you can ask, all right, is there a way that we could rewrite the sentence to say the same thing with a strong verb? So I'm going to set another timer here. Now you're only going to have 3 minutes, but hopefully it should be fast to find some of these is's and haves. All right, and we're going to start. All right, so now if we come back, hopefully we were able to find some weak verbs somewhere and some hidden abstract nouns that we were able to suggest. Okay, maybe we want to rewrite that. Okay, so moving on now to the third. I am at home, like a lot of people working from home nowadays. And hold on. Okay, so the third trick that we're going to search for now is specifying your antecedents. So antecedents, what are they? They are a noun to which a pronoun refers to. And in particular, the pronoun that I mean here is it, this, that, and who. And these are pronouns that we use often in our writing so that we don't have to keep reusing the noun again and again and again, because that can get a little bit boring. But sometimes we forget to specify which noun we're talking about, especially in science writing. There's a lot of different nouns that we're talking to at once because we have complex topics. So it's important to specify which one you're referring to. So for example, the sentence, "This shows that it is correct." That is a grammatically correct sentence, but it's a little hard to understand. Like, imagine if I was reading a paper and I put it down for a second to like go grab my coffee, I come back and I'm like, "This shows that it is correct." I have to be like, okay, what was this again? And what was it? And so how are these two things now related? A better way to write this would be to identify, okay, this is what we call an unattended this. This should always be followed by a specification of what that noun fit into. This is actually one of the most common problems I see in science writing, and I see it in my own writing too. It's the thing I most often look for is whenever I see the word this, is like, do I specify what this was? And then it, here, this is a vague it. So it, whenever you use it in a sentence, it should refer to the last noun that you use. So what was the last noun that was like the proper noun in that sentence? If, especially in this case, we have this and then it, like we know that this and it are not the same thing. Which one's referring to the noun from the last sentence? And which one's referring to the object? So a better way to rewrite this sentence would be to say that like this calculation shows that our theory is correct. So by saying this calculation, we don't have to like repeat the calculation, but we are referring to like this what. We're referring to like what that what was. And then we just went ahead and just changed it to our theory. Like, let's just make that a little bit more specific, because obviously we've shown like this calculation, we're now talking about something else. We need to remind you what it was when we're saying this and then it. So going back, another peer editing, I want you to check for specific antecedents. So one of the quickest checks that I do is every single time I write anything is I check, is there an unattended this? Like a this is, a this proves, this shows. Check for those. If you have a this and a verb, check and see if there's like something that you can say like what this was. Was this a calculation? Was this data? Was this a theory? Put that in there and specify that this. Was there a vague it, that, or who? Do you see anything that says it is correct or that does not? And does it always correspond to the last specified noun? Sometimes when we're using it, we can get a little bit lazy, or sometimes it's that we've rewritten the sentence before it and then we forget that the it is no longer referring to the main noun in that previous sentence. So go through and just go ahead and highlight anytime you see a this, an it, a that, or who, and make sure that they're always being specified. Okay. Hopefully we were able to find some unattended thises. Honestly, I find them in nearly everything that I end up going back and writing. I think it's everyone's favorite thing to do is just write this verb, this verb. So hopefully we were able to find some of those and circle them and figure out how they could be attended, what they were referring to. So now we'll go on to our fourth trick here. And this trick is to break up long noun strings. So noun strings are something that I think they're very specific to science writing, because scientists, we do love our noun strings, and there's a lot of like official noun strings that we use that builds up our jargon. So what is a noun string? When one or more noun directly modifies another noun, that creates a noun string. These are also called compound nouns. It's basically we just take a bunch of nouns and we've shoved them all together. And noun strings are actually very useful when they're limited to 2 or 3 nouns max, because they allow us to say things a little bit more succinctly. But once they get beyond 2 or 3 nouns, it kind of becomes this mess of we don't understand how things are related. So an example of a few noun strings, one of them is reaction rate. So that's a noun string. Reaction is a noun, rate is a noun, and we know that reaction is modifying the word rate. Another noun string, this is a 3 noun string, resource allocation modification. Okay, it's kind of, that's a lot, but that is a noun string that lets us know that there's resource allocation, and it's modifying the word modification. And here we have a 6-word noun string, significant, international, social, and policy attention. So that's 6 words, including the word and it's all modifying the word attention. So once you start to get to these really large noun strings, they get a little bit difficult on the reader because they're reading each noun in a row and they know that everything is modifying everything else, but they haven't gotten to that last word until the end. So for example, we don't know this, in this last example, we don't know that the attracted, that verb is going to be applied to the word attention until we've read through each of these 5 other words before it. And so I have to hold a lot of different things of significant, international, social, policy, all of these things are modifying this word, and I don't get to what that word is until the very, very end. And that's a lot of things to hold in my head as the reader. So in a way to make it easier for a reader to understand all of these noun strings that we've created, we can use prepositional phrases. So a preposition is of, in, from, on, at, by, to, or with. There's a whole bunch more, but those are some of the most common ones. Prepositional phrases, maybe we can just insert them into the middle of our noun strings to help show the reader how these things are related. And it also helps us move the final noun, the thing that's getting modified by all the other nouns, to a little bit earlier so that our reader can get to that important noun first. So for example, we could even take reaction rate and we can call it a rate of reaction. This is correct, and I've seen it written some ways. I actually, in most cases, will tell people don't write rate of reaction, write it as reaction rate, because another problem is that in a lot of sentences that are quite long, you'll end up with many prepositions. So if you start getting a sentence with like 3 or even just 2 prepositions, you'd be like, okay, there's a lot going on here. There's a lot of things modifying other things. So in the case of rate of reaction, it's a two-word noun string, write reaction rate instead. But a word like resource allocation modification of resource allocation actually makes a little bit more sense. I know I'm dealing with a modification of this other thing. And of course, this 6-word noun string, this is one we definitely want to break up. We could rewrite significant, international, social, and policy attention instead as is significant attention from social scientists and policymakers. It says the same thing, but we've moved that important noun, attention, much closer to the verb, so it's easier to read. And you notice we've actually taken out the word international. It's not really needed as long as you're saying scientists and policymakers and we're not specifying it's from a particular nation, your reader can pretty much assume that it's going to be international. So we're going to go through this piece that we have. We're going to give you 3 more minutes. I want you to take a look for any noun strings. Do you see any nouns that are back to back built up on each other? And if you do, can you break them up with a preposition? But likewise, also see if there's any sentences with multiple prepositions. Do you see any sentences that use the word of maybe 2 or 3 times in the same sentence? And maybe see if there's somewhere where we can use a noun string of 2 or 3 words to make the sentence a little bit more condensed and have less prepositions. So I'm going to give you guys 3 more minutes. Okay. All right, so now we're going to move on to the very last trick that we look for, and this one is a big one. This one is jargon, which I think we're all familiar with. Maybe we've gotten called out on it before. Maybe we've experienced other people using jargon that we don't know, but jargon is a major one that it really kind of interferes with us connecting and communicating well with our audience. So this is the Quantum Institute here, so I just went and took a guess of like, here's some jargon that we're all probably familiar with here, like qubit, superposition, circuit, information. These are all words that as physicists, they have a lot of meaning to us, but depending on the audience that we're writing for, they may not have any meaning at all, or even worse, they might have a meaning to our audience that doesn't mean the same thing to us. So if you are going to write an article for the general public and you use the word measurement when you're talking about a quantum experiment, the word measurement definitely means something to a general audience, but it may not mean the same thing that you're intending for it to mean when you're talking about a quantum experiment. So we always need to be very cognizant of what our audience knows when we're picking jargon. So jargon does have a purpose though, because like as physicists, if we're going to be talking about something that is like very complicated and we're talking about it day in, day out and expanding and building upon it, we need to come up with words to mean succinctly what we mean. So there's this great book by Randall Munroe. He's the author of the XKCD comics. He has a book called The Thing Explainer, in which he uses the 1,000 most common words to explain complicated topics. So here's an example page about cells. And he calls cells tiny bags of water you're made of, because these he's got 1,000 words he's allowed to choose from. And he tries to get into the specifics of how things work. So he talks about the outside wall, which is water bags make up animals, have soft walls. The bags in trees and flowers, which don't need to move around as much, have a less soft outside layer. So something like less soft outside layer, saying that again and again and again as we're trying to like do research and science on it, it's going to get very confusing. So that's why we've invented jargon, and jargon's very, very useful. And if your audience knows the jargon, it's easier to use it than to not, and to try and avoid it. Like one time I was sitting in a physics talk, and it took me forever to figure out what they were talking about, because they were trying to talk about vectors, but they didn't want to use the word vector. And so they just kept using other ways to explain what a vector was. And I spent the entire time being like, I have no idea what they're talking about. Because once you know the jargon, you expect people to use it. So this is one of those cases where you really want to know your audience very well. And so I created this flowchart of, depending on what your audience knows, you start here. Like when you have a jargon word and you're like, should I use it or not? You need to ask, does your audience for sure know this word? And if they know the word, like use the word, because that you've determined your audience will know this. It'll be fine. If you're not for sure, like know that your audience knows this word, then you want to wonder, like, will you use this word or acronym multiple times? And if you do, you should use the word. You should use it and then immediately define it, so that every time you use it afterwards, you know that your reader knows what this word means. However, there's some instances where we want to use a word, like I want to write an article and I want to mention qubits, but I'm never going to reuse the word qubit again, because perhaps this article is not actually about qubits, it's about something else, and I just need to reference qubit just for one time. In that case, it's not worth it for me to say the word qubit and then define it for my reader, because then we're going to end up in a situation where our audience is wondering, like, is this important? Why am I going to teach them a word that I'm never going to use once again? Because if I do that for every single word they don't know, I'm actually writing a textbook. I'm not writing a story at that point. And so if I'm only going to use the word once and I'm never going to use it again, don't bother using the word and then defining it. Just find a different way to write it. Like instead of saying qubits, I could say the bit for a quantum computer. Done. I don't even need to use the word and then define it, because the audience doesn't need to know, because I'm not going to be reusing it. So there's another instance when jargon comes in with numbers. So everyone knows what numbers are. That's the great thing about math. Like we've all learned the language of math, we should be able to use them. But there comes a time when, like with some numbers, we develop a familiarity with what that means, and we forget that people not in the field don't have that same association. So like, for example, 1,000 degrees Celsius, if someone's working in a lab, a condensed matter lab that deals with high temperatures, they have a feeling for like, what does 1,000 degrees Celsius mean? That a normal person has no idea how hot that means. So if you're writing a paper that's not for the very specific, condensed matter field that uses these high temperatures, you might instead want to say like the temperature of molten lava. This might be something you'd write in like a science article or in a general public article. You want to give people an idea of what does this temperature look like. Similarly, like saying like a femtosecond, it's 10 to the minus 15 seconds. How, like, as a general audience doesn't know what 10 to the minus 15 really means. Like, is that incredibly small? So you might write instead like that's a millionth of a billionth of a second. I was like, okay, that's tiny. Or similarly, a California fire is 400,000 acres large. That's not a fire from this year that I'm aware of. This was actually a fire about 2 years ago. It was 400,000 acres large. And I, as someone who I didn't grow up around acres, I have no idea how large that is. I looked it up. That's half the size of Rhode Island. That has a lot more meaning to your audience when they're like, oh, that's half the size of Rhode Island. I know kind of an idea of how big Rhode Island is. So numbers are, even though most people can read numbers and understand, okay, all right, I can relate it to that, they're a great instance to take a moment and make something concrete for your audience. In that way, they're kind of like jargon in that, like, we need to put them in terms that the reader's going to understand, because the reader is not going to be like 400,000 acres. Like, I wonder how large that is. And then they're going to pick up their phone and like do the calculation. They're not going to do that. And you don't want them to do that, because once they pick up their phone and Google how big is 400,000 acres, they're gone. They're on a Google tunnel at that point, and they're not coming back to your article. So we're going to go for it. It's our very last peer editing session. Thank you guys for sticking through this so much. I know we're just a little bit over time. So maybe instead of 4 minutes, I'm just going to give you guys 3. But I want you guys to go through the paper that you have and check for any numbers that are in here. Like, do they need context? And are there any jargon words? When you were first given your paper by your partner, hopefully they told you who the intended audience was. Maybe write down, like, do you think the intended audience knows this word or this concept? And if not, check if it's defined. Or if it is defined, check if it's used again. Because if it's not, maybe they don't need to define it. They could just say it in a different way. So I'm going to give you guys just 3 minutes here so we can wrap things up. All right. Thanks, you guys, coming back. I know we're running just a little bit over time, so hopefully we can just jump right back into our breakout rooms so we can share our papers back. So you guys are just going to meet with your partner again, send back that manuscript, maybe let them know real quick, like, this was the part where I thought the writing could be more clear. Let them know places you thought the writing was very clear, and maybe discuss, like, which trick did you use the most? Was it the voice, the strong words, the antecedents, jargon? Yeah, we could just jump into those rooms. I allocate 8 minutes because we're a bit over time here. Maybe we could cut that down. So thank you all for attending this workshop. Hopefully you've learned a bit about science writing and storytelling, and also quite a few editing tricks that you've now applied on someone else's writing and can apply to your own writing later. And you've gotten some good editing feedback from your peers. So thank you again for attending. And I wanted to just share like a little bit more, a few more resources if you want to learn more about this. So below I have like 3 books that are fantastic books for all this information. Joshua Schiemel's like Writing Science. It's a book about how to write science papers and grant applications. And when I taught a science writing class at Gilla, this was the book that we based it upon. Writing Science in Plain English is a great way to figure out how to take science sentences and like extra wordy sentences and write them in a clear way. A lot of the examples that we went through today were borrowed from this book. And then it was the best of sentences, it was the worst of sentences. This is for really like a lot of the writers in the room here, so it has nothing to do with science. This is like a writing book, and it's about how to take wordy sentences and make them very, very clear. So again, that 3rd book has nothing to do with science writing, but just writing itself. And then if you are a scientist that's interested in learning how to write science for the general public, there's 2 programs that I'm a part of that I would recommend. So NPR has a SciComm program. There's a link here. It used to be called Friends of Joe's Big Idea, which Joe's Big Idea was a podcast. It's now called the NPR SciComm program. They offer a free service. If you want to learn how to write, you can get set up with an editor. They'll go through with a month-long process teaching how to write an article, and then they help you pitch it to NPR or Science Magazine or the Smithsonian, but you can get it actually published in a real publication. And there's also Massive Science, which is a publication and program that teaches scientists how to write for the general public. And they have a class that teaches you how to write, and then you can even publish them in the science publication. So those are two great resources if you are very interested in science writing. Otherwise, I've also included my email. You can always contact me with questions about science writing, or even just, I'd be happy to send out these condensed slides to anyone who needs them. So that is it. I believe now we'll just go on to the other portion of this talk, which is the Q&A. So I'm gonna stop sharing my screen.
Awesome. Thank you very much, Catherine. That was very nice. I hope you guys enjoyed it as well. Yeah, so the idea of the last portion is just to have an open discussion about a bit about your experience and what you got from it. So I was wondering if you could start just to talk about, yeah, what was your experience from going to your PhD in physics to then your career?
Yeah, it was certainly it was a little bit of a scary and like unknown transition because I was graduating with my PhD, and I'd go around and like, you know, I'd talk to my advisor. I was like, I think I want to do science writing, and it's not a very common, it wasn't a very common path then. And so my advisor was like, I think that's a career, I'm not sure. And so it was a little bit scary at first because like, I'm not sure how to get into this. But once you kind of dive into science writing, you'll see that there's a lot of different resources for scientists to learn how to write science. And so from there, I got involved with NPR and Massive, and I went to a science writers retreat, which was hosted by some of the New York Times science writers. So writers are they're friendly people, and they love to share what they know. They love to share their tricks and their tips. So there's a lot of information out there to get you started. So I originally became the science writer for JILA, and I was I was writing their general audience articles. So I would just take all the research that was being published and I would rewrite them for the general audience. And I would also teach a science writing class while I was there. I then got involved as an editor for NPR's science writers program. So that's where I learned how to coach scientists into writing for the general public. And then lastly, up until recently, I was working at IBM as their media producer. So that was some writing, but also it was storytelling in a different format. So we would look at like events and videos and like all the different formats you could begin to tell science stories other than just writing. And so all of that ended up being very exciting and really eye-opening to learn that like there's so many different opportunities if you have a big science background, but what you really want to do is tell stories.
Oh, very nice. Yeah, and how do you feel like your your physics background helped you, or what were the challenges maybe?
The physics background, it's both helpful and in many ways a curse. So it's helpful in that when I speak with physicists about their research, I can very quickly catch on to like, oh, okay, you mean this, you mean that. And so sometimes if the physicist doesn't have a lot of expertise in their own and like communicating to the general public, I can kind of piece it together. Like I can meet them on the science level and be like, oh, you mean this and that and that. But it's a curse in the fact that sometimes it's hard for me to remember what the general public knows and doesn't know. Because when you've been studying physics yourself for 10 years, it can get difficult to remember that like, oh yeah, the word measurement doesn't mean everything. Like the word exponential is not a normal word to be using in everyday life if you're not a physicist. So sometimes it's hard for me to write to the general public when I'm writing specifically about physics research. I actually excel in writing about other science because for me, I can relate more with like, okay, what does the general audience know?
That's great. If you guys have questions, don't hesitate to ask them or to put them in comment. I can ask them for you if you will. I think we wanted to talk a bit about representativity and inclusion and diversity. So can you talk a bit about, you know, as a woman in science, and you've seen the academic side, but also the industry side of this. So what is your vision on this and what works?
what is my vision and what works? I feel like I'm still trying to figure out what exactly works. My vision is hopefully that academia can become more diverse and inclusive. So there's a significant lack of representation of women, but even more so in people of color. And that really starts from the bottom up. And industry has a leg up on academia, because with industry, they have HR departments and they have the ability to fire people. And so people in industry are a little bit more aware of how to be inclusive, and they're trying to make steps for diversity. Academia is still learning its steps there, in that if someone's not being inclusive, it's hard to have repercussions for that in academia. But what my vision is it was actually one of the reasons that I got involved in science communication, is that I really thought that communication, like scientists being able to communicate well, would help make science more inclusive in a way. Because like I would find that when I'd go to science conferences and I'd watch someone's talk and I wouldn't quite understand, I was like, oh, okay, I don't know what that jargon word means. So I go and I'd ask them. That every once in a while, not every physicist by far, but every once in a while there would be a physicist that I felt like would talk down to me about that. And then I'd wonder, I'm like, oh, are they doing that because I'm a woman or because I'm young? And it would make me like not feel good and wouldn't make me want to participate much more in the conference and networking with people. And I thought like, well, if scientists were just better at communicating their science from the get-go, like I wouldn't need to go and ask, oh, what's this jargon word? What's this other word? And like it would make it more inclusive, because people from no matter where they start, you know, whether they had a strong math background as a child or perhaps they had remedial math teachers when they were growing up, they would be able to understand the science and what we're trying to communicate if we're all much better communicators.
Yeah, that's great. Do you guys have questions? I want to take the monopoly. Could you talk a little bit about? Yeah, sorry.
Oh, it just showed me on my Zoom that Thomas Baker has a raised hand.
Oh yeah.
Well, if you want to ask your question, go ahead. You're on a roll.
No, go ahead. No, go ahead. Please,
okay.
Please go ahead, Thomas.
Okay, so I have just I don't know how to phrase this articulately, but I kind of wanted to ask what your experience was, because you've done this for a couple of more years than I have. So in my PhD, they heavily emphasize this narrative style. So a lot of the people who weren't sort of as active, they would have programs set up so that they would go and pull these people out of their research groups to sort of as a creative outlet, I would say, for what they were doing. And it was sort of heavily emphasized on imposing the NPR narrative structure on their talks and on their writing and things like this. And I had some experience writing for the NPR show, The Lowdown on Science, where you really had to pay attention to these things, and you couldn't introduce more than 3 new things in a script and things like this. But I grew to really resent this. I love NPR. Like, This American Life has an awesome narrative structure. You know, the way that NPR phrases things, they do this. But I almost wonder, as just kind of a philosophical thing, and I'm open to you have more experience. Please say no, that's bad, and why. I almost wonder if this is more of a disservice to the audience at some point. So I know some people who went way radical with this vision, to the point where their PhD theses sounded like a This American Life episode. There were no big words. There were no, super in-depth analysis of things. It was kept very close to home base, I guess is the way that I would say it. And I grew to really, really hate this. I think that including a lot of these elements can propel your research to a point where people will listen to you, and you should study it. I wonder if there's a caution about taking this too far. Like, one of the things about the passive voice is it keeps your attention. So, you know, this is the other thing.
Yeah.
So, but go ahead. Yeah.
The passive voice, like it keeps your attention on what you want your attention to be on. Like the example that we studied, like the undergraduates cooled the samples. It's like, we don't care that the undergraduates did that. What we care about is that the samples are cooled. So that's what we want the attention to be focused on, which is why I think it's important to know these tools, but then use them at your discretion. Like it's always important to know the rules and then break them when you see it to be appropriate. And I do agree with you that there is a point where it's not useful to implement all of these rules. Like you don't want to write your PhD thesis for a general audience because it's being written for a very specific group of people. Like, to be quite honest with you, unless you're doing like really groundbreaking research, like there's probably only going to be maybe couple hundred people that read your thesis. Like I hope there's not 1 million people that read my thesis. It's not appropriate for 1 million people. It was written for a highly technical audience. And in that case, like I want to use the jargon that they use. If I'm trying to avoid using that jargon, I'm just going to confuse them and I'm going to make it a lot more wordier than it needs to be. And wordier is also confusing. So it's really important to understand your audience and what they want to know. But I will argue that having that story structure is always going to be useful, even if it's just very subtly in there. I mean, you don't want to be like, this is the main character, you know, like I'm taking this atom, it's going to go on a wild adventure. Like that's not where we want to go with science writing that's meant for other scientists. But subtly having in a structure, the basic plot structure of this is what the world was like. This is a challenge of how we're going to change it. These are things that happened. This is what the world is like today. It's a little bit different. That kind of story structure I do think is appropriate for all writing. But I do agree with you, like it can be taken too far. You always need to know who is your audience and what do they want. Yeah, that was an excellent question and a very difficult one at that.
I've been through the apparatus, and I came out on the other side, and I was like, oh man, what are we doing?
You're like, yeah. It's like it sounds like burnout, but on a storytelling plane.
I just don't think it's a substitute. I think, but you know, your presentation was very good, and it was a great reminder of all these things, and I really appreciate it.
Yeah, no, I appreciate your honesty, and I agree. It's not a substitute. Like you need that substance there for sure, and you need to understand who your audience is. Yeah. Any other questions?
Maybe I will have one question. So I'm just curious about what was your motivation to do a transition from, let's say, a company in industry to being a freelancer? What are, let's say, the main challenges that you face now being an independent, being by yourself, essentially being an entrepreneur?
Yeah. My main motivation was working for a large company. I just think that it's not for everybody. So originally I got into science research because what I really wanted to figure out was like, what's the truth? Like, how does the universe works? And being raised in an academic atmosphere like grad school, I learned that you study things and then you share that knowledge with the world for free. That's how the academia works, and I really like that model. And working for an industry, it never really sat right with me that everything that I was doing was to make a company money, and that instead of thinking about like, what does my audience want, I was thinking more about like, what does my audience want so that they'll give us more money. And that was something that was very difficult with me. And I'm not saying like, oh, it's bad to have like, you know, a desire to make things money, because at the same time, like large companies need to make money so that they can make large changes that help the world. So I'm not going to say like, oh, large companies are all terrible. I just realized that for me, waking up every day, the motivation of making money wasn't something that really like sat well with me. And so I was like, I want to go the freelance route. Working as a freelancer, the pitfalls with that is that your income's really not steady. So working for a company, it's I kind of refer to it as kind of like the cruise ship version of life. It's like a vacation where everything's planned for you. You're on a large ship and they're like, here's your health insurance, here are your benefits, like everything's pretty much set. I just want you to work on this one thing. Being a freelancer, you have to know how to do everything. You need to know how to build a website. You need to know how to sell yourself, to contact editors at different places and build relationships with them. And you also need to know expertise in everything that you want to write. So if I want to write a story on electric cars, I need to go and become an expert on electric cars. It's a different process in that you need to be a jack of all trades. And then at the same time, like your income is not steady. So you need to take things into account, like, all right, if I'm only going to make this much this month, how am I going to make up for it in other months, and just kind of like budget and like keep things flat. So that was probably the biggest difference between working for industry versus being in freelance. And both of them are incredibly different from working in academia and working for a university as well, because in that case, you're also like, you have that steady life and that steady paycheck, and things are kind of taken care of. But at the same time, you're just working for knowledge. You're working to let people know things.
Yeah, thanks, Hannah. It was great. Thank you for the presentation as well.
Yeah, no, I'm glad you were able to make it. I'm glad you guys enjoyed it. Do you guys have any other questions for me?
Can I ask one other follow-up about what you said right before our discussion? So you said that you thought that the hiring and firing capability that the company had really helped to equalize things. But in where I come from, in my doctoral experience, almost a stunning fraction of the women were kicked out of the PhD program as sort of, you know, the way that the academic world in the US works to get rid of you is to pull your funding. And so there were 4 people that I remember very vividly, somebody coming into my office and telling me like what was going on, because we've been discussing it. And there was another person who had this happen too. I mean, do you have sort of maybe more details about your vision of how that helps? Because in my experience, it's only been that the biases of the principal investigators have slanted heavily against women in the sciences.
Yeah, I guess when I spoke to that like, you know, the hiring and firing isn't as present in academia, I was thinking more of the professor level when you get tenureship.
Oh,
yeah,
I see.
actually,
Okay.
I hadn't thought about that grad students, yeah, it's true, like for some grad students in some universities, like your funding and your job is more precarious. Luckily, I went to an institute where I don't think we had quite as many people lose their funding while they were grad students. Surprised to hear that, like for people, maybe I went to like a safer place. Certainly when I was a grad student, I was, you know, always worried. I was like, oh, my advisor's not gonna like this, they're gonna fire me. And after I left, I was like, I don't know why I was so worried. I was like, at some point you become an expert in your experiment, they can't afford to lose you. But yeah, so when I was speaking about that, of like the hiring and firing threat in industry isn't as common in academia, I was speaking more of like when you get up to the professor level, because certainly when you're a grad student and you're a postdoc, these are 6-year, 2 or 3-year jobs. Like at that case, you're maybe not looking at firing, but you're looking at like, you need to stay in the field, and your way of staying in the field is you need a recommendation from whoever is your PI. So that is true. So hopefully moving forward, like my vision is that like as professors become more aware of, okay, like, you know, we want to have inclusive and diverse people in this field, that they're going to encourage younger folks, so the grad students and the postdocs, to also have those values if they want a good recommendation to keep moving forward. But certainly like academia itself, the model, I think maybe, I don't know if it's ever going to get reevaluated, because at the same time, the mentor-mentee model is very good for teaching people these like very fine and nuanced details that you need to know in order to run like one of the most like impressive experiments in the world. Like I'm always kind of amazed at these like top cutting edge experiments are just built by a bunch of 20-something-year-olds who live in a lab and don't really, you know, they're not an electrician and they're not a plumber and they're not someone who knows how to, like, you know, woodwork, but somehow they managed to like kludge together this experiment and it's the best in the world at what it does. So while like that mentor-mentee relationship is very good in order to like build people who can do these really amazing things, at the same time, a mentor-mentee relationship, the fact that you're absolutely beholden to your mentor's recommendation in order to secure your next job is in itself a little bit unhealthy. Like if you don't have a great mentor, you're not going to be in a great place. So I do wonder if at one point we are going to like re-examine academic structure of the mentor-mentee relationship, but that's a huge question. There's pros and cons to it.
Thank you.
Yeah.
That was great. If no one else has a question, I think we'll wrap it up. Cal, do you agree?
Yeah, we're already a bit over, but it was a really great discussion, so I'm happy that we went over.
yeah, I'm happy too. So it was awesome. Thank you very much, Catherine, for the workshop and for all your time.
Yeah, thank you guys so much for having me. Sorry we went over a little bit, but it was so great to talk with you guys. And feel free to reach out in the future if you guys ever have any other questions about getting involved in science writing or ever just need an editor. I'm always happy to review stuff. So, all right. Thank you guys so much.